Alright, we will pick up where we left off. Let me just see if I can zoom in a little bit, and we will start just a little bit. Yeah, alright, that's enough. So basically we are told to graph f of x equals log x plus 2. Remember how we graph a logarithmic function? You start by making a table for the exponential function of the same base. So the fact that it is log, that basically means it has a base of 10. So let's go ahead and create an exponential. So my exponential parent function for that particular function is going to be y equals 10 to the power of x, and that's what I need to create a table for. Negative 1, 0, 1. So this will be 1/10, this will be 1, and this will be 10. And now when I do the inverse, because the log is inverse for the log, it's log of x, but all I need to do is to switch the x and the y. So this becomes 1/10, this becomes 1, this becomes 10, and my y values are the x values, negative 1, 0, 1. And then I want to plot this on the graph. But before I plot it, I just also want to pay attention to the asymptote. So this is a logarithmic function, which means it has, remember, logarithmic function have vertical asymptotes. Logs have vertical asymptotes, and in this vertical basically means how much it has moved up or down vertically. So it's basically a vertical line. So vertical asymptote is going to be how much is the it's going to be, you're going to look at how much this has shifted x. So it's going to be x equals to 0. Remember, vertical asymptote is a vertical line, and any vertical line is basically x equals to some value. So you have to basically look at how much the x value has shifted. The x is, there's been no horizontal shift, so it's going to be x equals to 0. So my vertical asymptote is going to be x equals to 0, and that's what and it will have none, no vertical asymptote. Okay, so let's go ahead and graph this. So first, going back to the table, you have these points. You're going to graph these lightly, and then what is my shift? My shift is, and then move 2 up, because there is no horizontal shift if you look at your original equation. So we're going to do this, we're going to graph this and lightly, and then so 1/10, when x is 1/10, my y is negative 1. So 1/10 is really close to 0, y is negative 1. This is my light point. And then x equals to 1, y equals to 0. And then x equals to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And y equals to 1, so somewhere here. But what do you do to this? You move each point 2 up. That's what we said. Graph this lightly and move it 2 up. So when I move this 2 up, 1, 2, I put a cross so that I can differentiate. 1, 2, I put a cross, and then 1, 2, I put a cross instead of a dot so I can differentiate. And I already know my vertical asymptote is x equals to 0. Okay, and now join these 3 points. So this is this point, and this point, and on the other side it is hugging the asymptote. So that is how my graph is going to look like. Alright, so let's look at this, my y-intercept. So the thing is, the graph is not touching anywhere on the y-axis. You see that it gets really close to the y-axis but doesn't touch it, so it is going to be none. And then we have the x-intercept. I see that it's touching the x-intercept at some point, and it's a point that's really close to 0. It's going to be a really small decimal value, but let's see what that value is. So this x-intercept basically means y equals to 0. That's what it means. And then how am I going to solve this? I'm going to substitute for x equals to 0 and try to solve this. So let's see. So f of x equals 0, log of x plus 2. And then I'm solving for x because I'm trying to find the x-intercept. Take it to the other side. Negative 2 equals log of x. How do I solve this? X is the input, so I want to make x the output. So you convert this into exponential. What is my base? My base is 10 to the power of negative 2 becomes my x. Therefore, x equals 1 over 100. And that is my x-intercept. My x-intercept is 1 over 100 comma 0, because y is 0. I'm just going to leave this here for anyone who wants to continue looking at it. My domain starts at 0, goes to infinity. Everybody should be able to see that, x values. My range is negative infinity to positive infinity. And then what do I have here? So they've already given me as x is going towards positive infinity. So x is going towards positive infinity, y is slowly increasing, but it's still increasing. So this is going to be positive infinity. As x is going towards, I cannot say negative infinity because x is not crossing the 0. So I'll have to say as x is going towards 0, from the positive side, right? Because we're approaching it from the positive side. So I'll say 0 plus, not from the negative side, from the positive side. My y is going down. So that's going to be negative infinity. There, I filled in all the values. Alright, so let's go to the next graph now. In the next graph, do the same thing. First, let's quickly look at the vertical asymptote. So this is a logarithmic graph. Logarithmic graphs have vertical asymptote, and vertical asymptote is basically, it's a vertical line. So it's x equals, so what is the x shift? So vertical asymptote is going to be x equal to negative 1. This is my vertical asymptote. And then I'm going to create my table looking at the base. So my base for this is e. So my parent function is going to be y equals e to the power of x, e to the power of x, negative 1, 0, 1. Sorry, yeah, here we go. E to the power of negative 1 is, basically we are looking at e to the power of x. So e to the power of negative 1 is 0.37. E to the power of 0 is 1. E to the power of 1 is 2.7. And then I switch. This becomes ln of x, or log of base e, and 0.37, 1, and 2.7, and negative 1, 0, 1. All right, let's go ahead and lightly graph this. Okay, so what do we do here? Let's go ahead and make sure that we... All right, so before I go on, I don't want to lightly graph this. I need to, because there's a stretch of 2, I'm going to straight away do 2y. I'm going to straight away do 2y. Because I can move horizontal, vertical, but multiplying it by 2, I need to do it on my table. So basically this becomes negative 2, this is still 0, becomes 2. I don't take this value, I take this value. And this is what I want to lightly graph. And then it says +1 on the horizontal, so that will be 1 going back. That's what we'll do. Alright, so let's go ahead and plot these. So when x equals 0.37, which is a little less than half, y equals negative 2. So 0.37, y equals negative 1, 2. So this is my light point. When x equals to 1, y equals to 0. When x equals to 2.7, y equals to 2. X equals to 1, 2, 2.7, y equals to 2. This is 2.7. Okay. And then all I have to do is move each of these points 1 back. That's what we said. So I move this 1 back. I move this 1 back. And I move this 1 back. This is close to this. And then we also talked about my vertical asymptote being negative 1. So this is where I draw my vertical asymptote. And then let's go ahead and join these 3 points. And on the other side too. So this is my logarithmic graph. This is my logarithmic graph. We can fill in the various values. So it's going through 0, 0. So that's basically going to be my y-intercept as well as x-intercept. My horizontal asymptote is none. My domain starts at negative 1 and goes to infinity, negative to positive. And they've already given me one end behavior. As x is going towards positive infinity, y is increasing. But as x is going towards, I cannot say negative infinity, x stops at negative 1. But from the positive side, so x is going towards negative 1 from this side, y is dropping down. It's the same. It's similar to the previous problem actually. There we go. Well, so this concludes day 3. We will pick up day 4 in the next set of videos.